Okay, we've got our midpoint right here, and these two lines are parallel. So I've got QD is parallel to UA. And they want us to prove that QAD is congruent. What I'm going to do is prove that it's a parallelogram, and then the parallelogram gives you two sides. You're probably going to have an angle already, so anyway, how are we going to do that? So R is the midpoint of QA. That's going to give me these two sides. These two parallel lines are going to give me that one, and then there's one more. And then I'm going to get these two vertical angles right here. What that does is gives me these two triangles congruent. I can then CP/CTC this side. Then I have a set of sides that's both congruent and parallel. That's going to make it a parallelogram. Once it's a parallelogram, then I can take and CP/CTC everything else that I want. So here we go. I'm going to take and start it off. I'm going to get R as the midpoint of QA. That's given. And that's going to make QR congruent to RA. Definition of midpoint. The next thing I'm going to do, I'm going to call this angle 1, angle 2, angle 3, angle 4. Angle 1, or angle 4 rather, is congruent to angle 3. Vertical angles are congruent. I'm then going to use my parallel lines here to get my last angle. Angle QD, or rather line QD is parallel to line QA. And that's going to be given. The next thing I've got is my angles. So angle 1 is congruent to angle 2 if lines parallel, alternate interior angles are congruent. And then from there, I'm going to grab, here's my side, here's my angle, here's my other angle. So angle, side, angle, triangle, yeah, triangle QRD is congruent to triangle ARU, and that's going to be ASA. From there, I'm going to CP/CTC the side that I want, so QD is congruent to UA, CP/CTC, and at this point, I'm going to call it as a parallelogram. So QUAD is parallelogram if opposite sides parallel and congruent. Here's where they're parallel, here's where they're congruent, then it's parallelogram. And then my final one on this one is going to be grabbing all those sides that I need for the triangles to be congruent. So I've already got angle 1 and angle 2. All I need is this other side right here. So I'm going to call it right now QU is congruent to DA if parallelogram, opposite sides congruent. And then I've got side that I've already proved, an angle that I've already proved. I just need that other side. I'm just grabbing the other side. QA is equal to QA. Reflexive. I probably could have done something different, but again, that's angle, side. Can't do that. Just going to grab all sides to be safe. So triangle, here's my side, and I've got the other side right. QR, where's my other side? Right there. Side, side, side. QAD is congruent to triangle AQU. Side, side, side. And that's it. Let's get on. So, on this one, we've got for each quadrilateral, this one, name, it's going to be parallelogram. How do I know the sides are not given as congruent? So these two are going to be the same. X is going to be 25. Y and 55 are going to be the same. And then Z, this whole thing is 80. So this Z is going to be the supplement, or 100. This one, all of these are the same. It's going to be a rhombus. 2x is going to be equal to 10. So 2x is equal to 16. X is equal to 8. This is a square. Or no, it's a rectangle. Why is it a rectangle? Because they don't give us all the sides. This is going to be equal to 3x plus 10. So subtract the 3, add the 8, and I'll get 2x rather, is equal to 18, so x is going to be equal to 9. Right here on this one, this is going to be a trapezoid. Why is it not an isosceles trapezoid? Those base angles are not the same. Since these two lines are parallel, I'm going to get supplementary angles. So 80 plus 100 is 180, 70 plus 110 is 180, and moving right along. This is going to be a rhombus. Again, they don't give us any angles. And I'm going to use a system of equation here. I'm going to get 9 is equal to 2x plus 3y. And I'm also going to get 5x, 9 is equal to 5x minus 6y. I'm going to use elimination. I'm going to multiply this equation by negative 2. That gives me negative 18 equals negative 4x plus or minus, oh wait, it's already, I don't need to flip the signs. They're already opposite. So positive 2 rather, positive 2, and that's going to give me a plus 6x. I will get 27, positive 18, so 27 equals 9x. So x is equal to 3. Once I get x equal to 3, I can go back in here. 9 is equal to 3 times 2x plus 3y. So subtract the 6 and I'll get 3 is equal to 3y. So y is equal to 1. Here I've got these two are listed as congruent. So 7x minus 2 is equal to 2x plus 8. Subtract the 2x, add the 2, and I will get 5x is equal to 10. So x is equal to 2. This is an isosceles trapezoid. They give me those two sides as equal. Right here, kite. This will give me another system of equation. So I'll have 4 is equal to 3x plus y. And I will have 12 is equal to 5x minus y. They set this up for elimination very nicely for us. 16 is equal to 8x. So x is equal to 2. That's going to make y negative. So I'll have 6 plus y is equal to 4. That makes y negative 2. This one is going to be a parallelogram. There we go. Parallelogram. I've got 30, 100 inside this triangle. I need another 50 to make that happen. These sides are parallel, so I've got 30 and 50 as well. That 100 is going to carry over here to the other side. So just filling in those numbers, 50 and 100 for W. This will be the last one that I do. These two are going to be equal, so I'll set those two equal. Subtract the 2, add the 2. I'll get 3x is equal to 12, x is equal to 4. Once I know that x is equal to 4, I'll put it back into this. So each side length is 18, and that makes y 18. And again, rhombus. Anyway, good luck.